Hello guys, welcome to another lesson. We are still on trigonometric integrals. Today we are looking at trigonometric integrals of the form sine power m x cosine power n x, where the m and n are not the same. So this simply means that the m and n can either be both odd but not the same values, or can be even or odd number. And with this, we will focus on these two examples. It says evaluate the integral of sine power 5x cosine cube x dx and the integral of sine power 5x cosine power 6x dx. Let's solve. So we have integral of, whenever we are to integrate integrals of sine and cosine where the powers are both odd, we can decide to split one of the factors of sine and then we introduce Pythagorean identity of sine, or you can also choose to split one of the factors of cosine and also introduce the Pythagorean identity of cosine. Either ways will work. So in this situation, let's split the cosine. So integral of sine power 5x cosine squared x cosine x dx. So here we are going to introduce the Pythagorean identity of cosine here. You know that cosine squared x is the same as 1 minus sine squared x. So this would replace the cosine squared x in this, and hence our integral becomes sine power 5x bracket 1 minus sine squared x then cosine x dx. We can multiply through by both the sine and the cosine. So let's deal with the sine first. We're going to get integral of this by that will give us sine power 5x minus sine power 7x multiplied by cosine x dx. Multiplying through by the cosine, we are going to get integral of cosine x sine power 5x minus cosine x sine power 7x dx. So applying the integral symbol and then variable of integration, we are going to get integral of cosine x sine power 5x dx minus integral of cosine x sine power 7x dx. We learned that anytime you have integral of cosine x sine power n x dx, that produces 1 on n plus 1 sine power n plus 1 x plus c. So in this situation, integral of cosine x sine power 5x will give us 1 on 6 sine power 6x, then minus integral of cosine sine power 7x dx also will give us 1 on 8 sine power 8x plus c, and that becomes the solution to the problem. Note that if you choose to split one of the factors of sine, the solution will be different. In this case, everything will be in terms of cosine. Both are correct. Then number 2. In this particular situation, we need to split the trig ratio with odd power. So we are going to get integral of sine power 4 x dot sine x cosine power 6x dx. Then again we expand this, and that will give us sine power squared x all by power 2 sine x cosine power 6x dx. We know that sine squared x is we need to substitute 1 minus cosine squared x in place of sine squared x. We're going to get integral of 1 minus cosine squared x squared by sine x cosine power 6 x. So we need to expand 1 minus cosine squared x all squared, and that will give us integral of 1 squared is 1, then 1 by cosine squared x, and that will be twice of that is 2 cosine squared x, then cosine squared x times cosine squared x will be plus cosine power 4x multiplying sine x cosine power 6x dx. Then we multiply through this by what we have here, and that will give us integral of this by 1 will be the same thing, sine x cosine power 6x dx. Then we're going to have minus integral of this by the whole of this will also be 2 sine x, then cosine squared x cosine power 6x will give us cosine power 8x then dx, and also cosine power 4x by what we have here will also give us plus integral of sine x cosine power 10x dx. So recall that we learned that integral of sine x cosine power n plus 1x dx should produce negative 1 on n plus 1 cosine power n plus 1 x plus c. So integral of this will produce minus 1 on 7. We increase this one by 1 cosine power 7x. Then the integral of this will also produce a negative value. Here is also negative, so that will be plus 2 on 9 cosine power 9x. Then integral of this will be minus 1 on 11 cosine power 11x plus c, and that is the solution to the problem. Thank you very much for watching. Please subscribe. Bye bye.